In this section, you learned about the pivotal role of neural networks in cybersecurity, focusing on how these advanced models can detect and mitigate cyber threats. You explored convolutional neural networks and their application in threat analysis, delving into their ability to process and recognize patterns in complex data, such as detecting malicious code or identifying anomalies in network traffic. The lesson on recurrent neural networks highlighted their effectiveness in cyber defense, particularly in analyzing sequences of data like login patterns and predicting potential breaches based on historical data. The exploration of autoencoders provided insight into anomaly detection, showcasing their ability to learn data representations and detect deviations from normal behavior, which is crucial for identifying unknown threats. This section also addressed the challenges and limitations of deep learning, emphasizing issues like the need for large datasets, computational resources, and the risk of adversarial attacks that can mislead neural networks. Additionally, the discussion covered the importance of model interpretability and the potential for overfitting, which underscores the necessity for rigorous testing and validation. Overall, you acquired a comprehensive understanding of how various neural network architectures contribute to cybersecurity. You learned to leverage the strengths of CNNs for visual data analysis, RNNs for temporal data, and autoencoders for anomaly detection, while also being mindful of the practical challenges these technologies entail. This knowledge equips you with the foundational skills to apply deep learning methodologies effectively in the field of cybersecurity, enhancing your ability to safeguard digital environments against evolving threats.